For numbers 9 and 10, find the following information for the given function, which is a rational function, and then graph. So in the lesson, some of the problems had holes and some of them had points crossing the horizontal asymptote. If they had a hole or a point crossing the horizontal asymptote, I put a blank for it. So notice number 9 only has 5 things to find instead of 7. The holes and the vertical points crossing the horizontal asymptote aren't on that one. But if you look at number 10 has a point crossing the horizontal asymptote. So because that has a line for it, then that one's going to have one. So just if there isn't a blank for it, that means not that I forgot it, but that I chose not to put it on there to try not to confuse you. So on the number 9, the domain, we find that by setting the denominator not equal to 0. So if I'm trying to find where x minus 2 is not allowed to be 0, so I add 2 to both sides and I get x can't be 2. So the domain is written in a way that we're talking about what we can have, not what we can't. So we're not allowed to have 2, but what are we allowed to have? Everything else. All real numbers, negative infinity all the way up into 2, union 2 to infinity. Everybody except 2 is allowed in our domain. The vertical asymptote is kind of similar to domain in that we're setting the denominator equal to 0, but we're just setting it equal to 0 and that's it. So I have x equals 2, which gets me equation of a vertical line, which is a vertical asymptote. The horizontal asymptote, we find that by using the chart. So I'm going to compare the degree in the top with the degree in the bottom. The degree in the top is 1, the degree in the bottom is also 1. So because I have the same degree in the numerator and the denominator, then I take 5 over 1, which is just 5. So we hit 5 over 1, which reduces to 5. The X Intercept, in order to find the X Intercept, I am going to set the whole function equal to 0. And we did that with several other things there throughout this test already. But in this particular case, when you set the whole thing, the whole function equal to 0, what we have is we have a cross multiply situation, and the denominator always multiplies out to 0. So I have 5x minus 6 times 1 is 5x minus 6. The denominator times 0 is always 0. So what we did instead of doing the whole function equal to 0 is really all you need to do is set the numerator equal to 0 and solve. Technically you could do the whole function, but it could save you one step by just setting the numerator equal to 0. So I'm getting x is equal to 6/5 for that one. So how do you write that? Well, it's an x-intercept. So 6/5 is the x-coordinate and 0 is the y-coordinate. And then for the last piece, which is the y-intercept, that's where I just plug in 0, f of 0, similar to how we found it in other problems. So I'm going to do, let's see, f of 0 is 5 times 0 minus 6 over 0 minus 2. So that's negative 6 over negative 2, which is positive 3. Okay, so I have some information. So we're going to go ahead and plot everything we know. I have a point at 0, 3. I have a point at 6/5, which is a little past 1, 0. I've got a horizontal asymptote at 5. And in orange, I have a vertical asymptote at 2. Okay, so looking at the information that we have so far, it looks like I can connect the 2 points and get really close to the asymptotes and get one whole branch. Now I need to find the other branch, and I'm not sure where it is. It could either be above the line, the horizontal asymptote, or it could be below, and I'm not sure, so I'm going to go ahead and pick a point. I can probably use a little bit of deduction here though. I know that there's only one x-intercept, and that's at 6/5. So if it was down here, notice it crosses the x-axis, and we know that it only crosses the x-axis once, so I don't think that's really an option. To be clear and to be sure, if I plug in 3, that will give me a point, and I think with pretty good certainty that it's going to be above the horizontal asymptote. So I take 3 times 5 minus 6, that's 15, minus 6, or 9. On the bottom I take 3 minus 2, which is 1. So at 3 I'm getting a point at 9. Okay, now I'm really sure that my branch must be above the horizontal asymptote. Make sure you put arrows on the ends of your branches, and we are done with that problem. Number 10, the domain. We said we were going to set the denominator not equal to 0. So we have x squared minus 4 is not equal to 0. I can factor that. So x can't be negative 2 and x can't be positive 2. So what can it be? Well, it can be anything from negative infinity up until negative 2, union negative 2 to 2, union 2 to infinity. The vertical asymptote is where they set the denominator equal to 0. So the two values were negative 2 and 2. Notice nothing divided out there in my numerator or denominator, which is why I don't have any holes. Because nothing divides out, I don't have a reduced form, so it doesn't really matter if you use which form you use, the factored or the unfactored. But if you had to cancel something out, then you have to use the reduced form. That's a little bit of a tricky situation. The next part is the horizontal asymptote, which we use the chart. And the chart compares the degree in the numerator with the degree in the denominator. So in this case, the degree in the numerator is 2, the degree in the denominator is also 2, which means that they're the same. So I take the leading coefficient 1 divided by the leading coefficient 1. That's just y equals 1. The point crossing the horizontal asymptote. So I have a point crossing the horizontal asymptote this time. So what I need to do is I need to set the horizontal asymptote equal to the function. So my function is x squared minus 2x minus 3 over x squared minus 4. And that's equal to my horizontal asymptote, which is 1, or 1 over 1 in this case. So when I cross multiply, I'm getting x squared minus 2x minus 3 times 1, which is itself, and x squared minus 4 times 1, which is itself. And now I get to solve. So I subtract x squared from both sides, which fortunately gets rid of the x squareds. So now this is a much more simple linear problem. So I'm just going to solve for x. And that gets me negative 2x equals, let's see, negative 4 minus, plus 3 is negative 1. And I'm getting x is equal to 1/2. So x equals 1/2 means the x coordinate is 1/2. The y coordinate is 1, and that comes from the horizontal asymptote. Clearly, if it's crossing the horizontal asymptote, it has to be on the horizontal asymptote, so the y value should have to be 1. The X intercept is where I set my numerator equal to 0. You could set your whole function equal to 0, but the denominator is going to multiply out to 0, so that doesn't really matter all that much. So I'm going to set my numerator, which is just x squared minus 2x minus 3 equal to 0. I already had factored that earlier, so that's x minus 3 and x plus 1. If I set each of those equal to 0, I'm getting x equals 3 and negative 1. So 3 is my x-coordinate of the x-intercept, and negative 1 is the x-coordinate of the x-intercept. And lastly, to get my y-intercept, I'm going to plug 0 into the function, which gets me 0 squared minus 2 times 0 minus 3. The numerator just gets me negative 3. Over 0 squared minus 4, which is just negative 4. So that reduces to 3/4. So when I plug in 0 for my x, my y turns out to be 3/4, which gets me my y-intercept. Now I'm going to plot all of the information that I have, all of the horizontal asymptotes, x-intercepts, y-intercepts. I have 2 vertical asymptotes at 2, and then negative 2. Okay, So I don't have everything I need. Oh, I have one more point. At 1/2, comma 1, it crosses the asymptote. Alright, so I think I have a lot of information here. The point 3, comma 0 tells me everything I need to know in the branch to the right. It has to approach the asymptotes and it has to go through the point. In the middle here, usually I have to get more points, but this is pretty clear. I can see that the is going down to the left, and because it crosses here already, I know it goes up to the right. The only thing I don't know is what's going on to the left of the vertical asymptotes. So I need to know what's going on over here, basically. So what I'm going to do is I'm going to plug in like -3. Plug it into the problem, so that gets me -3 squared is 9. -2 times -3, that's +6, minus 3 in the numerator. -3 squared is 9 minus 4, so that gets me 15 minus 3, that's 12 over 5. So when I plugged in -3, I get 12 over 5, which is 2 and some leftovers. So that's up there. So that tells me the rest of the branch must be above. I probably could have deduced that because there's only one x-intercept, so it couldn't be the bottom branch because then it would have another x-intercept. So that is my graph, and it's a pretty good graph, and I got lots of information on that.